Hello, my name is Dr. Rob Storrer. I'm an Associate Professor in Physical Geography at Sheffield Hallam University. And in this talk today, I'm going to explain how melting ice will affect people all around the world in the near future, but also how it's affecting people today. My background is I'm a glaciologist, which means that I study ice. So I'm often in places like Iceland or Sweden or Canada, looking at how ice affects the world. As part of that job, the main thing that I'm interested in are glaciers. You may or may not know what a glacier is, but there's a nice picture of a glacier here in Iceland. And a glacier, as it says on the screen, is a big mass of ice that's formed by snow falling and getting stacked up on top of other snow, and it eventually solidifies into ice. And a glacier is when that mass of ice is large enough that it is thick enough to actually deform and move under its own weight. So it's a big pile of snow, and once you get a few tens of meters of snow, then it's thick enough to actually move itself. And glaciers occur in lots of different places, and the smallest glaciers are about the size of a football pitch. So if you were standing next to it, you might think it's quite big. But in comparison, the very largest glaciers in the world are gargantuan. They are about the same size as an entire continent. And I'll show you some figures in a little while that will hopefully sort of give you an idea of how big some of the biggest glaciers in the world can be. So they do range in size enormously. The one in this picture is on the smaller side, but you can get some that are slightly smaller than that. During this talk, I'm going to talk about how glaciers and how they're changing at the moment affect people. And I'm going to focus on three key issues. I realise it says two on the slide. I'm going to talk about three. There are three there. So I'm going to talk about how glaciers affect people in terms of being water resources, how they affect people as hazards, and how they can affect people by rising sea level at global scales. First of all, let's think about, now that we know what a glacier is, where they occur. So this map is a map of the world, and the dark grey is the ocean, the light grey is the land. And in the blues and the whites, you can see where there are glaciers around the world. Across the world, there are about 200,000 glaciers, and they occur at all latitudes. So there are glaciers in South America near the equator, likewise in Africa and Indonesia. They tend to be in very high mountain environments. Because glaciers need two ingredients to exist. They need snow to build up, and they need cold temperatures so that that snow doesn't all melt away in the summer. What that means is that we tend to find glaciers in mountainous places and near the poles. So the North and the South Pole both have lots of glaciers, as do most of the mountain ranges in the world. And on this map, hopefully what you can see is that we have mountain ranges in South America, so the Andes, and North America, the Rockies, the Himalayas, stand out as some of these big mountain ranges that have lots of glaciers. There are other smaller ones as well, like the Alps or the Scandinavian mountains. We also have lots of ice in the Arctic, particularly on Greenland, and Greenland has what we call an ice sheet. This is one of these huge continental-sized glaciers. Similarly, the same can be said for Antarctica, where we have the Antarctic ice sheet, another huge accumulation of ice. So that's the context for what glaciers are and where they are found. Now I want to talk about how glaciers have changed and how they will change, because that change and that melting is the key part of this talk about how they're going to change and affect people. And we know from doing lots of scientific research that glaciers and the big ice sheets have changed in the past. On the left-hand side, there's a graph showing the mass change, so that means the melting, basically, of smaller glaciers across the globe. And without dwelling on this too much, the numbers here are the rate of melting per year. So this rate at the moment, most recently, is about 400 GT, which means gigatons. So that 1 gigaton is 1 billion tons, 1,000 million tons. So at the moment, glaciers around the world are losing about 400,000 million tons per year of ice due to melting. So they're getting smaller and smaller, and they're melting more and more. And this is for the smaller glaciers. You'll notice also that that rate is increasing. The melting is getting faster. On the right-hand side, the graph shows the information for the very largest glaciers, the ice sheets. So those are the Greenland and Antarctic ice sheets. And we know that Greenland is melting and it's losing lots and lots of mass. We've got different units here. Since about 1990, Greenland has lost about 4,000 billion tonnes. That's 4 million tonnes of ice. Now that is a staggeringly large number that's very difficult to imagine even what that looks like. Similarly, parts of Antarctica have lost thousands of billions of tonnes. Some parts of Antarctica perhaps lost less because they're still very, very cold. But the picture is that we know that the temperature has increased by about 1 degree in the last 100 years. We know similarly that the ice in most places around the world, not quite everywhere, but almost everywhere, has lost a huge amount of mass. So ice has been melting at quite high rates recently. So that's the past context, and we know that it has been affecting people as a result of that. If we turn our attention to the future, we can try to estimate what will happen to ice in the future. And the graphs that you can see here relate to Greenland in the north and Antarctica in the south, and those big ice sheets. And these graphs show what we expect the sea level around the world to do as a result of this ice melting. So when ice that's on land melts and goes into the sea, there's more water in the sea, so the sea level rises. And we expect Greenland to contribute a few centimetres of sea level rise over the next few decades. Antarctica, perhaps similar. Over longer timescales, we might expect quite a lot more. So we are expecting glaciers to continue that trend of increasingly rapid melt, and we expect to see that reflected in rising sea levels, amongst other things, as one of the predictions that we can make using models. This is a difficult thing to do, but we've been doing it for quite a few years, and the models do tend to perform fairly well. So that gives us a bit of a flavour of how glaciers have changed, how they might change as we go into the future. And now the key part of this talk is, what effect does that have on people? Not many people live in places where there are glaciers. And what you can see here on the left-hand side is a map of population density. So the shade of red on this map represents the number of people living in each area, the density of people, how many people occupy a particular amount of space. And what you can see if you compare the map on the left to the map on the right, which shows the same map of glaciers that I showed you earlier, is that actually most people don't live near or directly next to glaciers. And we tend to live in flatter, slightly milder climates because that's much better for building cities and agriculture than living up in the mountains in very cold and very extreme environments. However, we do still depend on glaciers, and there are quite a few people who do live near to glaciers. And you'll see on the screen a red box which is drawn mostly around India and the Indian subcontinent. On the left-hand side, you can see that there are a huge number of people living in this area. So the population density is very high. And on the right-hand side, you can see the Himalayan glaciers. So there are lots of glaciers in the Himalaya because it's a high mountainous environment. We've got nice cold temperatures there. There is a lot of ice in the Himalayas. And that ice is really important for the people in the Indian subcontinent because it's related to their water storage. So that brings me on to the first of the three ways that melting ice can affect people and will affect people, which is because glaciers are really important parts of the water cycle. So you may or may not know about the water cycle. You might have learned about it. You might be about to learn about it. But the water cycle, or the hydrological cycle in its basic state, means that water goes from the ocean and it evaporates and it forms clouds, and then it forms precipitation, rain and snow. It lands on the ground, goes into the rivers and returns back to the sea. So we've got this constant cycle of water. Now, the glaciers are a really important part of the water cycle because they act to store water. So when snow falls on the mountains, it gets trapped in glaciers because glaciers move very slowly for the most part. And glaciers can store water for a number of years or even centuries. So in places like India, which experience a monsoon climate where they have a very wet season and a very dry season, if you want a supply of water throughout the year because you want to drink water, you want to wash things, you want to grow crops, you need to have a reliable source of water. And if you have a climate that gives you a wet season and a dry season, you've got plenty of water in the wet season. Where do you get that water from in the dry season? Well, you get it from the rivers. And the satellite image that you can see in the middle of the screen here shows the Himalayan mountains at the top with their ice and glaciers in white. And then beneath that, we've got India and Bangladesh. And you can see lots of green because there's lots of agriculture, lots of things growing. And you can see some big rivers. This is the Ganges and the Brahmaputra rivers. And those rivers get their water from melting ice up in the Himalayas. And what that does is in the dry season, the ice continues to melt gradually. And so we have a constant supply of water, even in the dry season. So glaciers are really important as a water resource because they store that water, provide it to the people who want to use it in the dry season. And remember, there are lots of people who live in this area who depend on this water for their livelihood and their well-being. So glaciers are hugely important as water resources. And as they start to increasingly melt, they start to retreat, we're going to start to lose glaciers in some places, which means that storage starts to diminish. And in the dry season, some places will start to have shortages of water. So this is obviously going to impact people in many ways, whether it's agriculture or literally drinking water. As that becomes more scarce, people will have to adapt to that. And we'll talk a little bit more about that towards the end. So glaciers are really important as water resources. The second effect I'm going to mention is direct hazards that glaciers can pose. And this is particularly in mountainous areas. So on the left-hand side, you can see a lake, and lakes are really common in mountains where there are glaciers, because what tends to happen is a glacier is a big, heavy lump of ice and it's moving. And what it does is it carves out a little basin, and that basin becomes a hole that's filled with ice. But as you start to melt the ice, things change. The other thing that glaciers do is they bulldoze and they form their own dams, which we call moraines. So you can see in the picture here, there is a dam that's formed by a moraine because the ice has previously flowed down there and it's bulldozed rocks and gravel and sand into a big mound in front of it. What's happened then is the ice has started to melt and it's retreated and it's now found a bit higher up in the mountain. And so what it's done is it's left behind a dam and it's left behind that basin and it's been melting. So it's been turning that ice into water and that basin has filled up with water and we've got a lake in the basin. And the problem that we have here is that as glaciers start to melt and start to retreat, these lakes can get bigger and bigger. The dams that are holding the lakes back, made of these glacial moraines, are not concrete dams. These are dams that are made of very loose material, and so they are prone to breaking. And when you keep filling the water up, you put more and more pressure on the dams, and eventually you might get a breach, which means that lake can flow out of the dam catastrophically in maybe a number of hours. So we can get very big, very sudden floods in these mountainous areas. And this is made worse by the topography because when those floods happen, the water is concentrated in the bottom of the valleys and it flows down through the valleys very quickly. People tend to live, when they're living in mountainous areas, they tend to live in the valleys. So their buildings, their houses, their factories, their schools, their infrastructure will be in the valley bottoms. And that's where the floods take place. So these glacial floods can directly impact people's lives as well as their livelihoods. On the right-hand side, you can see an outburst flood that happened in Pakistan back in 2018. And you can see how the rock walls have constrained that flood water and it has impacted a settlement. downstream. And again, in the near future, as glaciers continue to retreat, we might expect to see more of these dangerous floods. The final thing that I want to talk about as an effect of melting ice on people is at a much bigger scale, and we're thinking now about the ocean and about sea level. I mentioned at the beginning that Greenland and Antarctica are very big, and it's really difficult to describe just how big they are. The numbers that I've given here are for Greenland. If you were to melt all of the ice in Greenland, you would raise the sea level around the entire world by just over 7 meters. So that is a colossal amount of water. Now, we're not suggesting that all of Greenland is about to melt. We don't think that that's happening. But it just gives you an idea of how much water is locked away as ice. Similarly, in Antarctica, lots and lots of water, much more, in fact, than Greenland. Antarctica is a vast continent, and it contains about 58 meters worth of water in the ice. If you were standing on the highest part of the Antarctic ice sheet, you could be standing on ice and you could look down, and beneath your feet, between you and the bedrock, there would be about 5 kilometers of ice. That's about 3 miles thickness of ice in the thickest parts of Antarctica. This is an incredible volume of water that's frozen away as ice. If you add up all the other glaciers in the world, all those 200,000 glaciers, they would contribute probably about 40 centimeters to global sea level. So the sea level can change quite a lot if we dial up the temperature of the Earth and we melt some of that ice. And so that has quite a significant implication for people. So let's come back to the people part of this. How is this going to impact people? Well, around the world, lots and lots of people, 700 million, live in what we call the low elevation coastal zone. So this is, if you take all the coastlines around the world, if you look at people who live less than 10 meters above the sea around the coast, there's about 700 million people who live in those areas. And we have a lot of what we call megacities, where millions of people live in cities, and lots of these megacities are coastal and they lie not far above modern sea level. And you can see some of those highlighted by the blue circles on this map. So there are concerns about what happens if the sea level rises enough to threaten these cities. And the impacts of that might be, in the long term, inundation of the cities. The sea might encroach into the cities. What will happen first is that when you get big storms, you get something called a storm surge, which is where the sea level, where the storm is happening, increases, and you get lots of waves coming in and the sea is higher generally. So when you have a storm surge, if you have a high tide as well, and if the sea level has raised because of melting ice, the impacts of that storm and of coastal flooding are going to get worse. And we can see here, by 2030, in places like China, there'll be more than 200 million people living in this low elevation coastal zone. So this potentially puts an awful lot of people at risk, both their lives, but also the infrastructure. If the cities are getting damaged, they have to be repaired or they have to be moved, and that has a big financial cost as well as the cost to people directly. So sea level rise is a really important thing to try to understand. So how is that going to change in the future? Well, we've seen that ice is melting, and we've seen that ice is likely to carry on melting, and it's going to speed up a little bit, regardless of what we do. But if we model different scenarios by looking at, do we stop burning fossil fuels or do we burn all our fossil fuels as quickly as possible, we can estimate how quickly the sea level will rise as a result. And usually we think that by the year 2100, so in about 80 years, the sea level is likely to rise by 50 centimeters to a meter as a result of this increasing melting. Now, there are places where we don't know very much about this, and it could actually be more than that. So we want to be really confident in these numbers. We want to know more about this because there's a lot of people and there's a lot of cities and there's a lot of infrastructure potentially at risk. So future sea level rise is a really important thing to understand. And if we take those three things that I've talked about, we take the water supply, we take the outburst floods, and we take sea level rise, we can see that these affect people in very different ways and at very different scales. Outburst floods happening within those valleys in the high mountains have profound impacts on people at a local scale. They don't tend to impact people everywhere in the world because they're quite small compared with the world, but very big if you're living in a village in the mountains. So outburst floods have quite severe local impacts. As soon as you start to dwindle the water storage in glaciers, you affect the water supply, and that again will affect people in the local area. But that can start to have a regional impact. If you remember the map of India and the Ganges River that comes from the Himalayas, that can start to have a more regional impact, and it can affect a lot more people. Similarly, coastal flooding as a result of sea level rise can start to go from local to regional, even to global scale impacts. But part of the complexity here is that this isn't just a physical geography problem. This isn't just that ice melts, this water comes higher. This is a problem that people make really complicated because we've built our cities in these vulnerable places, and we've invested lots of money, and we've got lots of people living in these vulnerable locations. And what that means is that as the water supplies start to be affected, and as we start to see increases in coastal flooding, that's going to lead to displacement of people. People are no longer going to be able to live in some of these places, and they're going to need to migrate and move to safer areas. And as soon as we start moving people around, and as soon as we start having less water supply, that leads to potential conflict and people fighting over water, which we have seen in places like India and Pakistan in recent years, where the water supply is dwindling, leading to people fighting over water and moving around. Similarly with agriculture, if food supplies start to dwindle, then people will start to fight over the food. And that starts to then build up to a global impact, which is something that we need to deal with. So I'd like to finish by summarising that really melting ice is affecting people now, and it will start to affect people more in the future. And it's made really complicated by politics and by geography, because as people, we're complex beings. So it's a complex problem, but I'd like to finish with some optimism, because there are solutions and there are things that we can do to stop this being as bad and to try and help. And the key thing is that people need to work together to try and reduce that impact and to try to mitigate against it. And partly that's with governments. Governments need to act to eliminate or to reduce greenhouse gas emissions, which will help to not melt so much ice. And so people can vote for governments that will help to do that. Another thing that we can do is try to create fairer societies, and that's from individuals all the way up to governments. All the impacts that I've talked about affect people differently, and they tend to affect poorer people more than they affect richer people. So by creating fairer societies, we can help people to become less vulnerable to these things, at the same time as that just being fairer anyway. And finally, we can develop technical solutions to try and counteract some of these problems. So an example of that in the Himalayas is that people have produced artificial glaciers that help to store water in the dry season and when the glaciers have vanished. So there are some technical solutions that we can do as well. So we need people to learn more about these things. We'd like people to come and study ice and glaciers, to learn more about the problems, so that you can be part of the solution and help that global problem and help to limit it and make the world a better place for lots of people. So I hope you found that interesting and useful. If you have any questions, please feel free to get in touch with me. But thank you for watching.